Hey there, and welcome to the Sudo Show, brought to you by the Destination Linux Network. Today, we'll continue our discussion around cloud-native architecture. We'll cover how applications have evolved in a cloud-native world, a bit of history, and how this radical transformation has made application management easier than ever. All that and more on the Sudo Show. Welcome to the Sudo Show, your home for all things enterprise open source. I'm Eric the IT guy, and joining me every episode is my slightly tablet-addicted co-host, Brandon Johnson. How you doing today, buddy?
So I did tell you, it looks like the Pine tab is going to be shipping soon, and I'm really looking forward to that. I pre-ordered that a couple months ago now, and yeah, I've been really chomping at the bit for that. This week, we did a lot of work. I actually got a pull request sent out for an open source project I've been interested in, and maybe we'll talk about that in another episode. But yeah, not a whole lot going on for me. I hear you've been working with a few projects the last couple of weeks. Care to share it?
Yeah, so I finally made it back to the gym for the first time, and I'm not going to admit on air how long, but finally made it back there, so I'm feeling good and ready to rock. And I've had a little bit of lab envy chatting with our Matrix community the past couple of weeks, so I finally got back to a project we talked about a few episodes ago, Podman. I'm migrating some of my Docker workloads onto my Fedora servers under Podman. Like any good sysadmin, I started with Minecraft server, and I'm building out from there. Once I spin up a few more containers, I think I want to be just about ready to implement some cloud management around these services. Anywhere I might be able to find some good tutorials?
Actually, I do. I just finished recording a deep dive about Mist.io. Should be available on YouTube now. If not, it'll be released here anytime. I've been very impressed with the number of providers that Mist.io works with. And it's encouraged me to look at other VPS and cloud providers that I've never heard of or just never given a second thought.
That is really great. If you missed episode 5, we talked about managing on-prem and public infrastructure using tools such as Mist, ManageIQ, Terraform, Ansible. We had a lot of great feedback, and it sounds like many in our community are kicking the tires on Mist specifically.
Yeah, Mist is pretty slick. If you know Ansible and, of course, generic scripting, you're going to be able to jump right in. As I mentioned in one of my latest blog posts, Mist is the lowest barrier to entry for cloud management. Make sure to write your integrations with solid secrets management, with well-documented APIs and solid CLI interfaces. Like with Bitwarden, I just started using the CLI for Bitwarden, and I love it.
Okay, so stop what you're doing right now. Pause this podcast and head over to bitwarden.com/DLN. Unless you're driving, in which case, pull over first. Why? Because Bitwarden is the easiest and safest way for individuals, teams, and business organizations to store, share, and sync sensitive data. If that wasn't enough reason to use it, Bitwarden is 100% open source and our preferred tool for password management. Just this past week, in fact, I realized there is an easy way to bring even more security into my home. While I've been a happy Bitwarden customer for some time now, I realized that my significant other was still depending on her memory or various built-in password managers to track all of her online accounts. This can be so frustrating when you're trying to log in on different devices. So in our house, we're actually going to upgrade to the family sharing plan. With the family sharing plan, you get all of the power of the premium plan, like 2-factor logins and health reports, but you can also share with up to 5 users. That means that Cynthia and I can use secure passwords on all her accounts, and for those services that we share, like Disney Plus, anyone, there's no more asking what the password is for this account or that. We get all of that for $1 a month.
And to borrow a phrase, some people might say that's darn near free.
No doubt. So go secure your family's accounts with a free trial at bitwarden.com/DLN. Thank you to Bitwarden for sponsoring the Sudo Show and the entire Destination Linux Network. We have a very big show today, but before we dive in, there's one more announcement we wanted to share with you. Mark your calendars for our first ever Ask Me Anything or AMA episode. On September 23rd at 7 p.m. UTC or 3 p.m. Eastern Daylight Time, we will be recording episode 8 live. We'll have an online meeting room where you can log in and, you guessed it, ask us anything. It can be about careers, education, open source, anything. Get subscribed for our next episode and stay connected with us on social media for more details soon. Remember, mark your calendars for September 23rd, 7 to 9 p.m. UTC.
So in our last episode, we talked about managing your cloud infrastructure, whether that was on-prem or public cloud. We're going to talk about cloud application architecture, which also translates into cloud infrastructure architecture. In its simplest form, each component of your application or infrastructure can be independently scaled. Compare that to traditional application and infrastructure architecture. Traditional applications and an infrastructure get deployed in a very monolithic fashion. Some get deployed on a single server with all the application components just on one box. You have a second server with all those same components for failover. Storage is likely shared using SAN, NFS, or some sort of network file system like GFS2 or something similar.
I know that monolithic applications have been the bane of many of our existences. From a maintenance perspective, it's a nightmare. I mean, if you want to update any component, say the database, the entire application has to be taken offline. The work executed, the application restarted and tested, then you can put it back into production. This type of architecture is what leads many IT professionals into working long nights or weekends. I know when I was doing systems administration work, a lot of times these windows wouldn't start until 10 or 11 o'clock at night. You had to wait until everyone from the East Coast to the West Coast had possibly logged out before you could actually take the application offline. This has gotten even harder because many apps these days are 24/7, so there is no downtime. So that brings us to a new generation of application.
In an effort to improve resiliency, developers starting building applications into a three-tier architecture. So the web tier, the application tier, and your data tier. Usually those are separated, running independently, but it starts to look like and sound like what cloud native architecture, but it isn't exactly. In traditional three-tier architecture, the application layer may not be able to scale out, only up, and it's tied to the same restrictions I just described. And the data tier may be a database that doesn't have the ability to scale out, but that can still be a limitation in cloud native architecture since the world still runs on SQL.
With the arrival of three-tier applications, clusters and load balancers started to make their entrance into architecture. You could then run multiple databases instances together in a cluster. Your web tier can be scaled out to have multiple nodes abstracted behind a load balancer. This made maintenance so much easier because you could take down a system or two at a time, run your patches and updates, and then put them back into the load. So your application would never go offline. Instead, you just decrease your total capacity for your application during the maintenance window. This brought about redundancy and fault tolerance. Unless you lost an entire tier, your application would still be online. This also started to pave the way for geographically diverse applications, basically running a small environment in multiple regions to decrease latency.
Now, the three-tier architecture was built for the early web. As we entered the hyperscale era, the profile had to change, and you had to break apart your application so your API and front-end services could scale independent of the back-end services, which also could be several different components as well. Breaking up these applications into smaller services is often referred to as cloud architecture or microservices architecture, and possibly also known as 12-factor applications.
With this type of application development, you've really started to get into concepts like auto-scaling, self-healing, and the big one these days seems to be orchestration. These are some of the core foundations of container architecture. How would you say that container architecture borrows from cloud architecture?
Container architecture is basically still cloud architecture. It just brings in a different dynamic. In the case of traditional cloud infrastructure, you need to keep components of your application running at all times because the startup time of a new VM takes too long, whether you are on-premise or in the public cloud. Containers startup time is much lower. Some container native applications can take advantage of low start time by scaling to zero using technologies like Knative and Kubernetes, and only use resources when a component of the application needs to be used.
I've also noticed some applications that use basically a warm start, where they may not necessarily scale to zero, but they scale down to one. So there's always a process ready to go, something sitting idle. So the moment you get that transaction request, you already have a process that's sitting there, spun up, ready to go, and that decreases latency even further when you're dealing with something that's very, very time sensitive.
Good point, Eric. And in what I just described, scaling to zero, this concept is called serverless. Whereas I prefer to call it function as a service. I actually think serverless is bad branding because there's still an application server. There's still hardware or VM to run on. But because it's become an industry term, I'll probably continue to use it, even though I don't like it. But some serverless or function as a service technologies do use VMs underneath the covers. But instead of VMs doing some magic to make startup time faster, serverless in public cloud infrastructure is really important so that you only pay for your usage. You don't want to pay for infrastructure you aren't using. You only want to pay for that usage at your peak or when the application is actually being used. Well-integrated container platforms solve this for you. Of course, there are all the public cloud service providers offer. They're really easy to consume, whether that's their traditional services or their container services. Also, because containers can go away at any time. Another really key difference between traditional cloud infrastructure architecture is persistence needs to be stored outside of the container. So whether that's a database, object, or file storage for the application data, a time series database for metrics, etc. Well-designed cloud applications, not necessarily containers, do this. This was one of the early intent of OpenStack-based applications. But at the time, at least from my experience, it seemed like everyone just wanted a VMware replacement, not AWS in their data center. So that whole concept of stateless applications was just delayed until the containers took the world by storm. Even today with containers, some vendors are doing what they did when cloud native architecture originally came on the scene almost 10 years ago. What they did back then, and like I've seen this all over the place, they just took the software vendors, they just did a physical to virtual conversion of their applications. Or if it was already virtualized, they just converted it so it would run on AWS or on OpenStack or some other platform. And it kept a lot of the same constructs and concepts from the tier 3 or even just the other traditional architectures. They didn't really evolve it to become cloud native. They just did that conversion and called it a day. Eventually their apps evolved and it became something that kind of sort of resembled cloud native. And now in the container space, I've seen some attempt to do the exact same thing. Just take the virtual machines they created and just convert them into containers. So you end up with these massive containers that just don't scale very well. And they're still treating containers like VMs that maintain their own state. Thankfully, that is less prevalent in the new container era versus the early public cloud, private cloud with OpenStack days. So the calls for lift and shift workloads now are very, very low. It's all about re-architecting them. One of the great advantages that containers give users is that it's not carrying a lot of that baggage because they are not doing that lift and shift motion. Also, containers are way more portable than a virtual machine. With a virtual machine, you have to convert it so it will run on the respective, like if you're moving it from VMware to OpenStack or from VMware to AWS or whatever public cloud provider you're using, you need to convert it. Containers, you don't need to do that. Way more portable. Containers give you the flexibility to move between different cloud providers because they provide the interfaces, or you can bring your own interfaces to run those containers.
That brings up a really good point. It's tempting to lock yourself or your company into one of these cloud providers and use their branded services. Why not just use a paid service and make a cloud provider manage all the underlying infrastructure? It's unfortunate that this is such a common practice today because it brings with it a lot of risk. First, you have the problem of cost. Many times, serverless as a paid product is much more expensive per transaction than running your functions in a container orchestrator like Kubernetes. It's a lot cheaper to manage the infrastructure yourself and use a platform-independent tool like Knative. Convenience comes at a cost, and if you're running thousands of transactions per day, that cost can become substantial.
Yeah, that kind of leads into a conversation of going multi-cloud. But there's a huge downside to going multi-cloud or even moving off of one cloud to another, and that's data mobility. It can be very costly to transport your data out of a cloud or move it between one cloud and another.
It's almost like Hotel California. You can check in, but you can't check out.
Indeed, there's but there are ways to solve the data mobility problem, and there are some open source solutions that can solve that, and I'll talk about those in a later episode. Open source solutions like Nuba really help with that problem, but unless you have the money to drop your own data connections into your cloud provider's data centers, data mobility without it costing a small fortune is really difficult. It's not impossible, but it is really difficult.
One of the problems we see a lot of times is that for-profit companies will utilize open source projects without donating resources or even contributing code back to the upstream projects. This, in fact, has pushed a couple of FOSS projects to change their licenses to become, for lack of a better description, less open source. It's critical to the continued development of open source projects that companies contribute code or resources, even financial resources, to help maintain and grow these projects.
Eric, exactly. I mean, it's one thing to consume it. It's another thing to contribute. The other day, I saw a report from the Linux Foundation that showed community contributions. I think it's obvious. Red Hat was at the top, but you can also tell who's contributing and who's promoting open source. And for me, it's still a shocker whenever I see it because I'm still used to the old Microsoft. Microsoft was number 2 on this list. Great seeing huge cloud providers like Microsoft and Google and IBM, and of course, Red Hat, keeping those contributions up. I really like seeing those providers putting their resources into the open source community because that's where all the new innovation is happening.
We'll put a copy of that report in the show notes so you can go and read it yourselves. I'm really shocked at how much things have changed since some of the initial reports of projects changing their licenses and that kind of thing have come out, that I think a lot of these big service providers realize just how much they depend on these open source projects in order to make their businesses run. Whether it's altruism or self-preservation, these open source projects are seeing huge influx of code commits from the likes of companies like Microsoft, people that a decade ago had a much, shall we say,
different opinion,
less optimistic view. Exactly. So I think our goal right now is to build a mental model for each of you over into what a successful and scalable application and infrastructure model looks like in today's cloud-heavy world. And we're doing so without a dependence on buzzword-heavy descriptions or proprietary solutions. Like today, we discussed at a high level what a resilient and scalable application looks like. Last episode, we talked about tools to help manage your infrastructure, whether it's in your company data center or on a public cloud.
In our intro arc, Eric and I talked about getting involved in open source to get into or expand your career in technology. Well, there's a great way to expand your portfolio with a project sponsored by the DLN community, the DLN Quality Control Platform. This platform will allow developers to find users that are willing to volunteer their hardware to test specific use cases for open source software being developed. There have been bottlenecks where developers are building features. And the example that I know Ryan gave in the Destination Linux podcast, episode number 186. Developers are making applications that are high DPI, but they don't have a high DPI monitor to test the results. If you have the skills and want to help make this work, head on over to the DLN Discourse Forum and see what you can do to help.
If you've been looking for a way to contribute that isn't code, this is a great way to dive in, especially if you're a hardware nerd like Brandon over here and his tablets. This project is still forming, so stay tuned for more information. Lastly, on today's episode, we wanted to try out a new segment. We're affectionately calling this the Productivity Corner. One of my motivators for hosting the Sudo show and writing blog posts and doing all the things that I'm working on is to help my fellow technologists get more out of their lives by enjoying a healthier work-life balance.
We've all been feeling the strain working from home or just that limited time in the office. Eric and I have even admitted in the last episode about missing airports of all things.
You know, I really wish I could tell my 2019 self that one day you'll miss going through the security line. For me, though, one of the ways that I maintain my enthusiasm is by keeping a morning routine, and we just wanted to take a minute and talk about what that looks like and why it's important. So I set my alarm for the same time every day. I'm out of bed by 7:30. I usually start by clearing all my notifications and checking out my calendar. That just lets me know before I get into the deep part of my morning routine if there's going to be some kind of an emergency or some kind of fire that's going to require my attention first thing in the morning. After that, I shower and get dressed. While that may seem ridiculous to mention, it really is important. This is a habit I've held since the days I worked 100% of the time in the office, even back when I was in school. It helps prepare my mind for a day of productivity. So I shower and put on clothes that I normally wear to an office. I sit down at my computer and I eat some breakfast while doing some mundane tasks, like responding to emails or scheduling customer calls. What this does is this helps me get some quick wins. I'm addicted to my Todoist, as I'm sure I've mentioned on this show before. So by getting some quick wins, it helps me get going by being able to quickly mark off a few tasks on my list. By the time I'm done with breakfast, my mind and my energy levels are primed to get some serious work done. So, Brandon, I know you're as particular about your morning routine as I am. You want to tell folks what your mornings look like?
My routine has been pretty strict. It's been this way for probably now 10 years now. But typically I get up between 5:45 and 6:15 every day. I use an app called Sleep Cycle. It monitors my sleep and it gently wakes me between those times.
Oh, I love Sleep Cycle. For those that don't know, Sleep Cycle monitors the noise levels in the room to try to determine what phase of sleep you're in. You give the app a 30-minute window, and it targets a time in that window where you're in the lightest sleep. It then quietly sounds a gentle alarm to help you wake up. I've used it for a couple of years, and it's actually helped me combat insomnia or even just waking up in a bad mood.
Yeah, it definitely improved my wake up mood for sure. As soon as I get up, I work out, shower, get dressed. I have a cup of coffee while reading my local newspaper on my tablet. And that's assuming someone didn't schedule a 6:30 a.m. Call on my calendar. If people are considerate and don't schedule that 6 a.m. or 6:30 a.m. call that I need to attend, I will take a look at my schedule so I know when I need to make that long commute to my home office in the basement. And and I also look at the tasks I need to complete for the day. And by the time I get down to my office for work, I'm on my third cup of coffee. So.
Now, I don't know about all the caffeine that Brandon drinks, but having such a simple habit doesn't seem like it would do all that much, but you'd be surprised. I can tell on days where I haven't followed my routine, and it throws me off. It throws off my rhythm. But when I'm able to go through my process and start the day the way I want to, it's so productive.
Yeah, and when I'm able to follow my morning routine, I'm way more productive. And I actually, because I'm more energized, I actually have more fun while working.
Fun while working. I'm not sure if that's allowed. We'll have to check company policy. So this segment is an experiment, so please let us know what you think. Just shoot an email over to contact@sudo.show. And as always, thank you all so much for joining us today. I know there's a ton of content out there. There's a whole bunch of shows and podcasts and articles that you could read. So every time you download and listen to the show, we're very grateful that you chose to spend some time with us on Sudo Show. If you'd like more of our content, you can find it over at sudo.show and on social media at Sudo Show Podcast. And you can catch more awesome content over at our network partners at destinationlinux.network. Brandon, anywhere you want to send folks?
You can follow me on Twitter at dbrandonjohnson or my website, open-tech.net. And I want to thank everyone who visited my site lately. The traffic to my website has just exploded.
Yeah, aren't you the popular one? And if you want to help me in the analytics wars that Brandon and I have going on, you can follow me at ITGuyEric on social media or on itguyeric.com. Remember, the Sudo Show is your place for all things enterprise open source. Until next time.